In this video, we are going to discuss the nature of the roots. Now, the solution of a quadratic equation ax square plus bx plus c equal to 0, where your a is not equal to 0, is x equal to minus b plus minus under root of b square minus 4ac divided by 2a. Now this is the quadratic formula, and using this formula we can find the roots of any quadratic equation, right? Now let's observe b square minus 4ac, that is this part. Here you have a, b and c, right? You have a, b and c and all are constants, right? A, b and c are constants. That means if we substitute these values here, we are also going to get the constant value for b square minus 4ac, right? Now this constant, that means the value for b square minus 4ac can be either 0 or b square minus 4ac can be less than 0 or it can also be greater than 0, right? So let's see what happens to the roots of a quadratic equation in each of the three cases. So if my b square minus 4ac is less than 0, that is, it is negative, what will happen in that case? We will have b square here, b square minus 4ac equal to less than 0. That means this number will be negative number. But we know that the root over the negative number does not exist, right? It does not exist. So this quadratic equation will have no solution. In which case, when b square minus 4ac is less than 0. In that case, the equation will have no solution or it will have imaginary roots, right? Because then this part I will not be able to solve and hence the equation will have no roots. Second case is that if my b square minus 4ac is equal to 0, what happens at that time? This part, my roots at that time will be minus b plus minus 0 upon 2a, because this part is going to be 0, and another value, okay, this will be only plus, another will be minus b minus 0 upon 2a. Minus b plus 0 is equal to minus b by 2a. Minus b minus 0 is also equal to minus b by 2a. So the equation will have equal roots, minus b by 2a, comma minus b by 2a, and of course real also, right? So we have concluded that when b square minus 4ac is equal to 0, at that time the equation will have real and equal roots. Let's consider one more case. When my b square minus 4ac is greater than 0. In that case, I will have x equal to minus b plus under root of b square minus 4ac upon 2a, and x will also be equal to minus b minus under root of b square minus 4ac upon 2a. Now here one will be minus b plus something and another will be minus b minus something. That means I will have two distinct roots over here, right? But they will be real also. So when my b square minus 4ac is greater than 0, the equation is having real and distinct roots. The roots will be distinct, right? Now let's consider this b square minus 4ac. Let's talk about this again. This b square minus 4ac is called the discriminant. And you have seen that this discriminant helped us to find the nature of the rules without actually solving this quadratic equation. And b square minus 4ac, we denote this discriminant by capital D. So this D is very important because it helps us to find the nature of the roots without actually solving them. So let's recap what we have learned now. If D is less than 0, then what will be the nature of roots? The equation have no real roots. They will be known as imaginary roots, right? So if D is equal to 0, then the equation will have real and equal roots, and each of the roots will be minus b by 2a. If D is greater than 0, then the equation will have real and distinct roots, and the roots will be minus b plus minus b square minus 4ac upon 2a. Now we'll solve some sums based upon and find the nature of the roots in the next video.